Hello, everyone, and welcome to my presentation on building robust V2X communication networks in Go, scaling connected vehicle systems for urban mobility. My name is Utham Kumar, and I'm excited to show how Golang, often called Go, with its concurrency model and cloud native microservices, is pioneering safe, intelligent, and high throughput urban mobility. Over the next few minutes, we'll explore how connected vehicle systems leverage Go to enhance vehicle to everything communication, leading to more efficient traffic flow, improved safety, and truly transformative results for modern cities. Before we jump on to the technical deep dive, here is a quick introduction to my background. I spent over 20 years working on program and product management as well as end to end technology solutions. My master's in engineering comes from Nanyang Technological University, and I'm also a project management professional with advanced scaled agile certifications. In my roles at major enterprises like Visa, T-Mobile, Verizon, Lenovo, and IBM, I've seen how crucial innovation is for scaling global platforms, especially in the realm of connected vehicle systems. Recently, I've also been leveraging generative AI to accelerate product delivery and optimize operations. My global experience across the US, India, Japan, Singapore has shaped my approach to building robust, scalable solutions that meet the unique challenges of different markets. Now, let's talk about our focus for this section, focusing on how Go powers V2X solutions. Firstly, we'll explore Go's concurrency model and suit performance suit the high throughput demands of connected vehicle systems. Next, we'll discuss how pilot deployments of Go-based collision prevention services have shown up to reduce up to 40% in crash reduction. We'll then examine scalable intersection management in the cloud, processing thousands of vehicle interactions per second to cut congestions and emissions. And finally, we'll discuss DevOps best practice and how Go's concurrency patterns ensure fault tolerant, continuously deployed services at scale. Let's start by defining V2X communication. Now, V2X, like everyone knows, stands for vehicle to everything. It compasses vehicle to infrastructure, vehicle to pedestrian, everything, vehicle to everything communication. Essentially, it's about creating a unified network where vehicles, road infrastructure, and even pedestrians can communicate seamlessly. Now, the impact is significant. V2X can reduce collisions by up to 40%, improve traffic flow by 30%, and even more in certain markets, and accelerate emergency response times by 40%, which is very crucial. As for market growth, we are seeing at least around 18% of CAGR globally, with predictions that over half of all the new vehicles will have V2X capabilities by 2030. Now, that's a massive opportunity for anyone building or adopting V2X solutions. Now, let's look at why Go language is such a powerful choice for V2X communication systems. Now, Go's concurrency model is built around Go routines, lightweight threads that can handle thousands or even millions of simultaneous connections with minimal overhead. Channels provide a safe mechanism to pass data between these Go routines, preventing race conditions, which is critical when multiple vehicles share the time-sensitive data. This leads to a highly parallel event processing, perfect for reading sensor data from numerous vehicles in real time, whether for collision avoidance or dynamic routing, so on. In addition to concurrency, Go brings us top-notch performance. Now, let me dive into a little bit depth there. Low latency. Go's runtime is optimized for near instant startup times and minimal latency, which is vital when dealing with such kind of a safety-related vehicle operations, which is very important. Now, memory footprint. Go routines use far less memory than traditional OS threads, making them ideal for high connection counts in edge devices or embedded systems. Now, it's obvious why we'll need that. Profiling and optimization tools. Tools like ppprof and tracing help you constantly fine-tune performance, identifying bottlenecks in real time so that you can deliver the fastest possible response for V2X events. And everyone understands why. Further to that, just on my previous slide, let's look at some performance benchmarks. Now, under 100 milliseconds end-to-end latency is critical for collision avoidance. Now, you need this because you need a near instant reaction time. And sustained 500,000 plus messages per second throughput handles the highest volume of data from sensors like GPS modules, traffic signals, so on and so forth. 99.99% uptime is achieved via circuit breakers and fault-tolerant architecture. In safety-critical apps, high availability is a mandatory must. 25% of performance gain was achieved through iterative tuning with Go's profiling tools, showing how continuous optimization pays off. These figures demonstrate Go's ability to deliver on the rigorous demands of V2X. Now, let's go on to some more advantages. Another key advantage that is Go's robust standard library. Now, networking and cryptography, inbuilt packages, making socket programming straightforward, and the crypto libraries handle encrypted, authenticated data exchanges between crucial for V2X security. HTTP, JSON, etc. Go standard library supports common web protocols and data encoding out of the box. This is essential for over-the-air updates, telemetry APIs, or communication with cloud services. Now, this out-of-the-box support speeds up development timelines and ensures consistent, secure data handling across V2X networks. That's one of the major things in current vehicle-to-vehicle communication. Let's see what these features mean in practice. Go's real-world capabilities. High throughput concurrency. Go's Go routines handle thousands of vehicle interactions in real time, crucial for traffic optimization. Mission-critical microservices. Pilot deployments show up to 40% crash reductions in collision prevention systems built with Go. Cloud-native scalability. Go's lightweight threads and network libraries scale horizontally on container orchestration platforms like Kubernetes. DevOps and resilience. Go's fast build times foster continuous delivery, ensuring quick rollouts of new safety features. IoT and edge compatibility. This is very crucial because minimal overhead means Go runs efficiently on distributed edge nodes, which is critical for real-time data processing in vehicles. Now, it's very clear why these capabilities combine to create a powerful foundation for any V2X solution. Let me move on. Here's a high-level view of how Go fits into the V2X architecture. You have key components like, for example, you have the API gateways for secure vehicle telemetry ingestion, real-time messaging, example, NADS, Kafka, MQTT, to handle data streams and specialized analyticals and decision services for collision detection or route optimization. Scalability patterns. Deployed on Kubernetes, these Go microservices can scale elastically. Automated CI/CD pipelines and canary releases ensure zero downtime when rolling out updates. Data flows. Vehicles send data to an edge node running on Go-based processing, which communicates with cloud microservices. The system then aggregates, analyzes, and sends back the instructions or user notifications. We're talking about horizontal scaling that can handle up to 600,000 messages per second, delivering the real-time responsiveness demanded by modern cities. That's pretty huge. Moving on, beyond raw performance, developer productivity is also a major benefit. We can see why. Simple syntax, Go's minimalistic approach and built-in GoFMT results in uniform code style, fewer errors, and quicker onboarding. Now, that's very important. Static typing plus garbage collection balances type safety with modern memory management, making code more robust for large projects. Fast compilation, Go produces small binaries quickly, which is invaluable when deploying to vehicles or resource-constrained edge nodes. Now, this means faster iterations, fewer bugs, and a more efficient development cycle overall, which is a dream for any software development company. Let me move on. Security and privacy. Now, security is non-negotiable in connected vehicles, and Go has you covered. Multi-layer encryption, Go's TLS stack secures transmissions, ephemeral key rotation, prevents replay attacks. Advanced cryptography, elliptic curve, and post-quantum protocols are actively developed in the Go community. Simplified concurrency, because Go's concurrency is built in, you're less likely to introduce multi-threaded security flaws. Ensures Go's crypto libraries and concurrency model align with the high security standards required for connected automotive ecosystems. Another huge plus is Go's growing community and ecosystem. Now, you'll find abundant open source libraries for real-time streaming, messages queues, IoT integration frameworks. Now, accelerates your V2X development process. The active developer support means security patches, new libraries, and best practices are updated regularly, ensuring the ecosystem stays healthy and future-proof. Now, this collaborative environment can significantly cut down on development time and risk, which is very important for any V2X communication systems, just like any other high-priority systems. Now, let's see some ideal vehicle-to-vehicle or V2X communication use cases where Go really shines. Real-time data ingestion, handling sensor streams and GPS data from multiple vehicles simultaneously with no bottleneck whatsoever. collision prevention and safety, distributed algorithms running in parallel to extend situational awareness and trigger avoidance maneuvers, telemetry and diagnostics, collect engine, hardware, software metrics, and securely transfer them to cloud or edge service for analysis, which is very crucial. Integration with infrastructure, seamlessly connected through roadside units or traffic management centers, enabling advanced traffic optimizations and coordinated driving. These scenarios highlight Go's high concurrency, security, and lightweight approach, exactly what you need for a perfect V2X system. Moving on, here are the key takeaways if you're considering Go for your V2X communication. One, high concurrency for real-time data processing, simplicity that leads to rapid development and fewer bugs. Security stands via integrated cryptographic libraries, exceptional performance under heavy load, ideal for safety critical systems. These 4 points sum why Go stands out as a top contender for building robust, scalable, and secure V2X networks. Now, that wraps up our journey into building robust V2X communication networks in Go. Thank you so much for joining me today. I hope this session gives you a clear picture of how Go's concurrency model and cloud-native approach can elevate connected vehicle systems for urban mobility. If you have any questions about implementing Go in V2X or you'd like more in-depth technical resources, please feel free to reach out. Thank you once again for your time, and I look forward to continuing the conversation. Thank you very much.